Okay, in this video I'm going to talk about the difference between endothermic and exothermic reactions. Exothermic reactions are reactions where the atoms themselves move from a higher energy state to a lower energy state, and they become more stable from an energy perspective. That means that it would cost more energy to get them back out of this situation, or it means they're more likely to stay or remain as this type of atom. This energy change, let's say, for example, that they were at 0 energy and they moved down to -10, this 10 that we've lost here is available to the environment for other forms of energy, most typically in chemical reactions, an increase in temperature. Or, as we call it, heat. So energy was inside the particles. So here's our particles, and they had energy in them. And then they went to a state where they had less energy. So the energy came out of them. Let's just have it come out. And then in the environment, this was available to things like the motion of particles. Or as we refer to that, the temperature of the substance. Exothermic reactions are the more common type of reaction, but it's not the only thing. Particles don't always just go to lower energy states. There are some reasons why particles might end up going from a low energy state to a high energy state. Typically this occurs if there's some sort of statistical reason why it's more likely for the reaction to happen one way than the other. If that does happen, we call those endothermic reactions. Here the particles are moving from a low energy state to a higher energy state. When they do that, you have to pay energy to get them to move up. What that means then, if let's say this one's 0 and this one's 10, then it's going to cost 10 to get up there. That 10 energy has to come from somewhere. So it comes from the environment. What that means then is these particles are actually going to a less stable state from an energy perspective. I know that should mean that it doesn't happen, but it can still happen. And when they absorb that energy from the environment itself has to have that energy in some way, so it's going to come from the motion of the particles. And so this is going to slow the particles, which means they get colder. And the way we look at this is it's like an absorption of heat. So in this case, the energy that was in the environment, here's your molecule and here's its final state, is going to go in here, and so we're going to have less energy in the environment. Endo means going in. So here we say energy is going into the particles. And that less energy is going to be realized by the environment as it getting colder. A lot of reactions actually will have an endothermic part and an exothermic part, and really what you're looking at is the comparison between the two things to figure out whether the total reaction ends up being endothermic or exothermic. We're going to discuss that idea in more detail later. Just a quick recap here then. Exothermic, energy, the particles going to a lower energy state. That means the energy is coming out of the particles and being realized out of the reactants and being realized as the motion of the particles in the environment, and that's going to cause the environment to heat up. If it went from 0 to 10, that 10 that gets released, or that 10 that's available, can be used as heat or as the speed of the particles. Energy is exiting that's why we say exothermic. Energy is exiting the particles and going into the environment. Endothermic, the particles are going from a low state of energy to a high state of energy. The energy is going into them, and so the environment itself has to give up that energy, and so it's getting colder.